Hello everyone. Time we try to do different repairs, not just TVs or just the phones, different things. That's how you keep the business going. Not like if I don't get the TVs, I'm out of the business, or if I don't get the phones, I'm out. Like trying to build the business that can fix most of the electronics, and the customer, they have one spot to go for all their electronics need. The customer bring it in, he said it doesn't charge. So this lithium battery is for the wheelchair, I think. And this is an expensive battery because this battery, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 40 cell of 3.7. This is 18,650. Is a regular cell, but 40 cell is to rebuild this battery. It's gonna cost like $5 for each cell. It times 40, it will be $200 just for the cells. That's without the labor. This battery is a 36 volt. You can see it, 36 volt, 10 amp hour. All right, let's start checking this one, see what's going on with it. Okay, we are in the DC and we are going to check. Yeah, to test the battery, don't test it from the, where is, this is the output. So we are not going to test it from this output because it sure is. Okay, let me turn it on. You can see there is no voltage the output. This battery, the company put a key on it to turn it on, to lock it, and to turn it on and off when it's not in use. And they said it here clearly, please turn off the power when not using it. And the customer told me he'll leave it on. So what could be happen is the battery drain. So I already removed this plastic cover. And or before we do anything, let's check the how much charge, or if this one is charging. This is the charger. The charger still green. The charger should, when it's detect the amps is going to the battery, it should be go solid red. It's still green. Yeah, the charger detects no amps going to the battery. Yep, no charge going to the battery. And the customer already told me he put it in the charge for a couple days with no luck. When you turn it on here, you push this power button, completely dead. So I want to check what's the charge in the cells before the board. This is a charging board here, the controller. You can see This board here is charged every pack of the cells alone. Like they can charge this ones and this ones. You can see the wires where it's go, and the other wires go in the other sides. So when this board, the controller in this board detect the cells are low, it won't give them the charge anymore. Or if it's detect like some battery cells are like up to 4 volt and the other ones is stuck at the 1 volt or 2 volt, the chip is going to stop sending the charge to the battery. So from the red wire to the black wire before the board, we have 5 volt. That's all we have. This is supposed to be 40 volt and we have 5 volt. The battery is not going to charge. And if we check from here to here, like this, like we're testing this cell here, 1 volt, 1 volt. Yeah, the cells is 1 volt. You can see them. Yeah, it's a 1 volt in the cell. Five volt. Alright, what we're gonna do is, so let's give the battery some charge. We're gonna connect it to the external power supply, give it a little bit boost to make it up to about like 30 volt, just a quick charge. Then we charge it with the regular charger, and we see if that's gonna work. Yes, this board or this module, if it's the battery very low, doesn't give enough power for the IC or the VCC, because the chip is need the VCC to work. If there is not enough VCC for the chip to work, the chip is not gonna allow the charge to go to the battery. If the chip detecting one battery is a full charge, in this case like a 4 volt, and other batteries has lower charge, is gonna cut the charge to all the battery. It's not a smart design, like it's gonna cut the charge going to the full charge battery cells and keep giving the charge to the other ones to get them all the full charge. Now if it's one battery charge faster, one battery cells charge faster than the other ones, and of course it's gonna get full charge quicker, and the module is gonna cut off the charge for all the battery. In that case, it will be the battery cells that charging slow. It's gonna be the bad battery cells. In our case, all the batteries has low voltage. All of them is very low. So we're gonna connect them to the external power supply and give them a little bit charge till over they are over 20 volt, and we connect them to a regular charger and see if we can get this light red. Plus we're going to check the voltage if it's increased using the regular charger. So we go to the maximum here is about 32.7. This is a 36 volt battery. So the red and the positive and the black, and the negative that's coming from the cells, not the negative that's coming out of the board. You can see that spark, and we have 1 amp, yeah, 1.5 amp. So just give enough amps. That's not gonna causing the battery wire, that's not causing these wires to get hot. You can see here the voltage is going up. So we give it like about 5 minutes or so. I do have 2 of these batteries. So when this battery left on, the module is like consuming the charge.
A few minutes later.
You can see it's at 32 volt now. $31 we have 6 volt, 6 volt, 6, 6, and 6. So all the cells, they have same voltage. All right, now we are gonna plug the charger and see what we're gonna get. Now we have the red light. It show here like when it's red, it should be like charging. And yeah, the multimeter is going to tell us if the battery cells are charging. So let's go from here to here. So 32.69, 32.7. Yep, the voltage is going up. 32.8. $32.9, and it's going. So I already put this one together. Already fixed this one and put it together, and this the same thing. I did charge it a little bit. So let's turn on the key. See, now we have the light, and we have 75%. So now they can charge fine. So I'm gonna leave this one on the charge for a couple hours.
Many months later.
Alright, we have the light now, and we have like 25%. So the battery is charging now.